Okay, to statistics stars. In this screencast, we're going to learn about relationships between two quantitative variables. Okay, and that's going to involve making a scatter plot to display that relationship. And then once we get the scatter plot, we're going to learn how to describe it using direction, form, and strength of a relationship. All right, so let's go. So way back in chapter 1, we displayed single quantitative variables using dot plots, stem plots, histograms, and box plots. Now we're going to talk about how to display the relationship between two quantitative variables, and we're going to use something called a scatter plot. Okay, so a scatter plot shows the relationship between two quantitative variables. They're quantitative, not categorical, measured on the same individuals. And we put the values of one variable on the horizontal axis and the values of the other variable on the vertical axis. So here's a scatter plot that shows the relationship between the weight in carats of diamonds versus the price. So the weight is the horizontal axis down here, and the price is the vertical axis. And you can see, not surprisingly, that as the weight of the diamonds increases, so does the price. And there's kind of a curvy relationship to it there. So how do we make a scatter plot? Well, you identify the variables and label the axes. For example, here the variables were the weight and the price. And you label the axes and you scale them, so the weight goes anywhere from 1 carat to more than almost 5 carats, and the price is going to go from 50,000 to 450,000. Wow, those are expensive. Okay, and then you plot the individual data values, which means you just plot your individual dots, and you make yourself what's called a scatter plot. Here's an example. Here are the 40-yard dash times in seconds and the long jump distances in inches for a small class of 12 students. Make a scatter plot that displays the relationship between the 40-yard dash time and the long jump distance. So they decided to put the dash time along the horizontal and the long jump distance on the vertical. And notice that our dash times are going from, well, it looks like the lowest is 5, a little more than 5. And the highest is, looks like 7 1/4. Okay, so they go from 5 to 7.5. And our distances are going from 65 inches for the long jump all the way up to, looks like the highest one is 184. So they're going from 60 to 200. Okay, and then you just plot the individual values and you get a scatter plot. Now you can see that there's kind of a weak association. Generally, your long jump distance is higher if you are a faster runner, if your dash time is lower. And the longer you take to run a dash, then the shorter your long jump distance, which makes sense. Okay, so you can go to your student resources in Sapling and choose the two quantitative variables applet, and you hit begin analysis, and it automatically creates a scatter plot for you, which is really nice. You can also do it on your calculator. Okay, so you're going to go to Stat, Edit. Let me make sure this is inside the screen here. Okay, so I've already entered these values. And I'm going to go to y equals, and I'm going to make sure I don't have anything there. I'm going to turn off plot 2. So I'm just going to hit enter. And then I'm going to go to second stat plot for plot 1. I'm going to turn plot 1 on. And I want to choose the first type, scatter plot. So I hit enter. My X list is L1, my Y list is L2. I like to use the little squares for the marks. And for my window, I'm simply going to hit zoom. And then number 9, zoom stat, and there it is. So there's the same scatter plot there that we got over in OneNote, which is right there. Yeah, so you see it's the same scatter plot. Okay, so there are 4 things we're going to discuss when we're describing a scatter plot. Direction, is it going kind of sloping down or is it sloping up? And if the slope is negative, if it's going down from left to right, then we say that that's a negative association. And if the slope is going up from left to right, then we say that it has a positive association. So the association matches the slope. Okay, a scatter plot can show a linear form or a nonlinear form. And obviously if it's linear, it's going to be looking like a line. Strength, a scatter plot can show weak, moderate, or strong association. And the association is strong if your individual points are kind of close to the line, okay? So if you've got a whole bunch of points that kind of follow the line, then you'd say it's a strong association. But if you have a scatter plot that looks like this, where the points are just kind of all over the place, that's a weak association. And of course, outliers are points that aren't near any other points in your data set. Okay, so here's an example. How fast are barefoot runners, and how long can you expect to live? So these are times without shoes, and these are times with shoes. And you can see this has a good linear association. We've got a couple of outliers here. It's positive, okay, because the slope is positive. This has a nonlinear association. It's doing a curve right there, okay, and not really many outliers on that one. Okay, so like I said, positive association, linear pattern. The association is strong. Two noticeable outliers on the shoe example. Okay, life expectancy. The higher your income, the higher your life expectancy. That's not surprising. And there's a positive association because it's generally increasing from left to right. And there's a curved nonlinear pattern, and these points are pretty close to that curve, so it's a strong association. And there don't appear to be any values that depart greatly from the curve pattern. So, hopefully, after this quick screencast, you now know how to do a scatter plot. And going back to our learning targets, and you can describe that scatter plot using the direction, form, and strength of a relationship.